Today onwards, we are going to start with oceanography. So, it is open for all. Anybody can attend this live classes, and these classes are precisely meant for acquainting you how to go about with geography, how to study a topic in a coherent and organized manner, so that concepts are sequentially established, and while writing answers that gets reflected, your clarity of thoughts get reflected in your answers. So this way, the sole objective of this live class is to make you understand the concepts and how to understand them in a sequential and organized manner, and how the topic is interrelated with other topics, how one topic is related with other topics. You must be well aware of that. Okay? So we'll start with oceanography. The oceans are very important. They account for 71% of the total Earth's surface. They account for 71% of the total Earth's surface. If you see in terms of area, the total Earth's surface, this is 51 crore square kilometer, out of which land, that accounts for 29% area, is 14.88 crore square kilometer, and the water bodies account for 71% of the total area. This is 36 crore square kilometer. That water bodies far exceed land area. See in your phone. Now, if you see, there are three water bodies that account for 90% of the total oceanic expanse. One, Pacific Ocean, that account for 16.5% of the Earth's surface. Second, Atlantic Ocean, that account for 8.2% of the total uh, Earth's surface. And Indian Ocean, this account for 7.3%. Basically, if you see oceanic expanse, uh, it's in crore, sorry, not percent, crore square kilometer. 8.2 crore square kilometer, 7.3 crore square kilometer, not percent. Pacific Ocean itself is larger than the total land area. The extent of Pacific Ocean is more than the entire land area, that is 16.5 crore square kilometer. These three oceans together account for 90% of the total water bodies on Earth's surface. The extent of Pacific Ocean is 16.5%, 16.5 crore square kilometer. Atlantic Ocean 8.2 crore square kilometer, Indian Ocean 7.3 crore square kilometer. These three bodies account for 90% of the total water bodies. Now, apart from these, if we talk about in, in intercontinental seas, Arctic Ocean. Arctic Ocean happens to be the largest ocean among intercontinental seas. Arctic Ocean is largest among intercontinental seas. That is which is surrounded by continents on all sides. If you see Arctic Ocean, and which is looking to North Pole, it surrounds North Pole on all sides, and it is bounded by America, Europe, Asia, Greenland on all sides. Among intercontinental seas, Arctic Ocean is largest. Hudson Bay is largest among smaller enclosed seas. Is largest among smaller enclosed seas. Enclosed seas कैसे होते हैं? जैसे you see Persian Gulf. It is surrounded by Arabia on one side, Africa on other side, in north by Sinai Peninsula, by narrow outlet of Bab al Mandab. It is connected to Bay of Bengal, Arabian Sea. So Persian Gulf, Red Sea is surrounded by Arabian Peninsula, Africa, in north by Sinai Peninsula. That is Red Sea. Red Sea is surrounded by land on three sides. By narrow outlet, it is connected to Arabian Sea. Likewise, Persian Gulf also. It is surrounded by Persia on one side, Saudi Arabia on other side, in north by Iraq and Kuwait. So it is also surrounded. So such seas are known as enclosed seas, which are surrounded by land on three sides, and by narrow outlet they are connected to open seas. It is largest among enclosed seas. Then among fringing seas, Bering Sea is the largest. Among fringing seas. Fringing seas are those seas which are bounded on one side by islands. If you see Sea of Okhotsk, this East China Sea, South China Sea, they are bounded by islands on one side. Among fringing seas are those seas which are bounded by islands on one side. Bering Sea happens to be the largest among them. Now, we are very much familiar that the northern hemisphere equator divides the earth into two hemispheres. This is northern hemisphere, this is southern hemisphere. Northern hemisphere is known as land hemisphere and southern hemisphere is known as water hemisphere. In northern hemisphere, out of total area, water bodies account for 60.7% of the total area of northern hemisphere. In southern hemisphere, water bodies account for 80.7% of 80.9% of total area. So in both hemisphere, water bodies dominate. But northern hemisphere is known as land hemisphere merely because out of total land area, 75% of land area on Earth's surface lies in northern hemisphere. So it is known as land hemisphere. Otherwise, in northern hemisphere also water bodies dominate. It is only between 45 north latitude and 70 north latitude. In northern hemisphere, it is only between these latitudes that land exceeds water bodies. In southern hemisphere, south of 70 south up to 90 south, it is Antarctica, where land is 100%. Land area accounts for total surface. Now, how do we demarcate oceans? कैसे हम लोग oceans की boundary demarcate करते हैं? How do we demarcate oceanic boundaries? You see, this is the world map. This is Atlantic Ocean, this is Indian Ocean, and this is Pacific Ocean in the east, and this is Pacific Ocean in the west. Now, on ocean, we demarcate the boundaries with the help of longitude, parallel meridians. Meridians are used to demarcate the boundaries. Like boundary between Pacific and Atlantic Ocean is demarcated from Cape Horn at the southern tip of South America, from Cape Horn, line running along 70-degree west longitude, 70-degree west longitude up to Southern Sea. This line joining Cape Horn and running along 70-degree west longitude up to Southern Sea, this acts as a boundary between Pacific Ocean and Atlantic Ocean. In case of bound in this eastern side, in the eastern side, the boundary between Atlantic Ocean and Indian Ocean, this is demarcated from Cape Agulhas, Cape Agulhas, and this runs along 20-degree east longitude, 20-degree east longitude up to Southern Sea, not up to Antarctica. This is Southern Sea. Line running along 20 degrees longitude up to Southern Sea. This acts as boundary between Atlantic Ocean and Indian Ocean. The boundary between Indian Ocean and Pacific Ocean runs along from Tasmania along 147 east longitude, 147-degree east longitude. This acts as boundary between Indian Ocean and Pacific Ocean. Although there was a scholar, Alfred Wallace, he was a British scholar, who also demarcated the boundary between Indian and Pacific Ocean in this part, that line running along Bali, Lombok and Philippines. This separates Indian Ocean from Pacific Ocean in this part. This is known as Wallace line. Wallace line. This separates Indian Ocean from Pacific Ocean in this part, running along Bali, Lombok and Philippines Islands. Now, this was general outlook about oceans. Now we are going to begin with this first topic. This was a brief outlook. I will also discuss about hypsometric curve or hypsographic curve later on, and how ocean bottom, while discussing ocean bottom relief, how ocean bottom, how do we study ocean bottom. But here first we will start with the first topic of oceanography, that is ocean currents. Ocean currents. Now, what are ocean currents? Ocean currents refer to horizontal movement of water, primarily under the frictional drag of planetary winds. Ocean currents happen to be a component of oceanic circulation. Now, what is oceanic circulation that we are going to demonstrate? Planetary winds, you might see trade winds, westerlies, polar easterlies. They blow over oceanic surface for considerable distance. Now, suppose this is any ocean in tropics. This is any ocean. In tropics, trade winds are blowing. Suppose planetary winds are blowing. So these winds exert frictional drag. Since they blow consistently over long distance, so under the frictional drag of these planetary winds, the surface water also starts moving. This white shows the movement of surface water. The surface water also starts moving under the frictional drag of these planetary winds. These are planetary winds. Suppose for this purpose it is trade winds. This is horizontal movement of surface water, what we call as ocean current. It exerts frictional drag and water starts moving. In trade winds, they blow from east to west, northeast to southwest. So they will drag the warm surface water from east to west. As a result, in tropical seas where trade winds blow, there's surplus piling up of water on the western side of the ocean. On the western side of the ocean, because of piling up of water, sea level rises. Sea level rises. As a result of this rise in sea level, the water starts sinking. Water starts sinking. This is known as downwelling. Downwelling. Because of piling up of water on the western side of tropical seas under the impact of trade winds, the surface water starts moving and gets piled up on the western side. So the sea level on the western side rises, and under the weight of the water, water starts sinking, that is downwelling. And on the oceanic bottom, if you see, on the oceanic bottom, it continues to move. This movement on the oceanic bottom is because of difference in temperature and salinity. On the ocean, this downwelling continues to move, and the surface water which is creeping on the oceanic surface, it moves very slowly, very slowly. One oceanic circulation requires hundreds of years to be completed. This surface water which is moving on the bottom of the sea is because of differences in temperature and salinity. Density of water is same, but the temperature and salinity is different. Because of that difference in temperature and salinity, the surface water continues to creep, continues to move. This is known as thermohaline circulation. It is very slow. And on the eastern side, what we see, where the under the frictional drag of planetary winds, the surface water has been removed. To compensate for this loss of water, water starts upwelling on the eastern side of the tropical seas. It is known as upwelling. This complete is oceanic circulation, and this horizontal component of this oceanic circulation that envisage horizontal movement of water, that is known as ocean current. That constitute ocean current. Ocean current plays a very important role in balancing the heat balance and global heat budget. It plays a very important role in balancing the global heat balance and exchange of heat between different latitudes. Now, here it appears as if planetary winds are the sole reason for the existence of ocean current. No, ocean current owes its existence not only to planetary winds. Planetary winds happen to be the most important factor behind ocean currents. But apart from it, ocean currents are the cumulative result of 12 factors. Ocean currents are the cumulative result of 12 factors. First, gravitational force is very important in causing ocean current. Coriolis force, another factor. Atmospheric pressure and its variation is a factor responsible for ocean currents. Then evaporation, it also causes ocean current. Precipitation, temperature difference in ocean, salinity difference, density difference, melting of ice, nature of coastline, ocean bottom topography, very important. All these factors cumulatively play an important role in causation of ocean current and planetary winds. So all these factors together account for ocean current. They are responsible for causation of ocean current. Yes. पूरा पुराना है. Now, ocean currents see, can be studied in two ways: on the basis of their strength and on the basis of their nature. They can be studied in two ways. One, on the basis of their strength, how strong the ocean current is. They are classified as o, drift, oceanic drift, ocean current, and stream. Drift, when the current is very slow moving. Drift, when the current is very slow moving, it is known as drift, slow moving current. Current, when the velocity of water is adequate, normal, adequate velocity, it is known as current. Stream, very strong current like Gulf Stream, when the velocity and the water is high, it is known as stream, strong. When the velocity is high, it is known as stream. On the basis of their nature, they are classified as cold current and warm current. Cold current, when the temperature of the ocean current is colder than the temperature of the ocean into which it moves, then it is known as cold current. Matlab, all the currents moving from poles to equator like Labrador current, Greenland current, Oashio current, they are cold current because the temperature of the current, water of the current, is colder than the ocean into which it moves. Warm current, when the temperature of the current is warmer than the temperature of the water body into which it moves. Like all the currents moving from tropics towards high latitudes are warm current. So on the basis of nature of temperature of the water involved in current vis-a-vis the water body into which it moves, they are defined as cold or warm current. Now, uh, let us start with the ocean currents of Atlantic Ocean. You need to open up your atlas because I'll be discussing locations, how these currents move, how do they impact. So you need to have the awareness about the coastline places. Now, this is Atlantic Ocean. This is Atlantic Ocean. This is equator. Now you see, if you see the shape of Atlantic Ocean, it is quite narrow in tropics. It broadens towards middle latitudes, again narrows down. But in southern hemisphere, it continues to broaden. In southern hemisphere, the extent of Atlantic Ocean is 5,900 kilometers. In but in tropical regions, it is very narrow. It is in tropics that the trade winds blow, under whose impact surface north and south equatorial currents are generated. Here but the extent of ocean is less. Since the extent of ocean is less in tropics, so the extent over which the trade winds will blow is also less. So these currents are not so strong. Under the impact of northeast trade winds, north equatorial current is generated, which moves from east to west. North equatorial current under the impact of northeast trade. Under the impact of southeast trades, south equatorial current is generated. Here you see the extent of Southern Atlantic Ocean is more as compared to North Atlantic Ocean. The extent of Southern Atlantic Ocean is 4. As a result, the winds blow over larger distance. As a result, the south equatorial current is stronger than north equatorial current. South equatorial current, although both are not so strong as north and south equatorial current of Pacific Ocean, because in Pacific Ocean it is extremely vast in tropics, so trade winds blow over considerable distance. But in case of Atlantic Ocean, the extent of ocean is less, so north and south equatorial current are not so strong. But comparison to north, south equatorial current is stronger because of larger extent of Atlantic Ocean. Now, these currents continue to pile up water on the western side. These currents pile up water on the western side. As a result, sea level on the western side gets raised. This happens in every tropical sea. The western part of tropical sea is always warmer and the sea level is higher. Water piles up. As a result, what happens? A slope gets formed from west to east. A slope gets formed from west to east. Under the impact of the slope, this warm water which is piled up on the western side, under the impact of the slope, surface warm water starts moving from west to east under the impact of the slope, which is known as counter current. It is warmer than north or south equatorial current. As a result of piling up of water, a slope comes into existence. As a result of slope, this counter current, it is a compensation current. Compensation current. It develops because of piling up of water. And this counter current, since it is the result of piling up of water, which results in the formation of slope, this counter current, by the time it reaches the eastern side, it becomes stronger. It is feeble and weak in western side, because if a body is moving under slope, by the time it will reach its eastern side, it will gain in velocity. Therefore, because of this slope, the counter current is stronger on the eastern side, where it is known as Guinea current. This counter current is known as Guinea current in the eastern side. This counter current is stronger in the eastern side because it is the result of slope. It is a compensation current, and it is warmer and stronger during northern summer. It is why it is stronger in the eastern side and it is stronger during northern summer. This is because, see, during northern summer, what happens? The southeast trades cross the equator and the southeast trades are stronger. And in Atlantic Ocean, the extent of Atlantic Ocean is more in the southern part. During northern summer, when the southeast trades are stronger, they will lead to huge piling up of water because they are stronger. And second, main reason is the extent of Atlantic Ocean is more in the southern side. So the strong southeast trade winds blows over considerable distance and pile up huge water on the western side during northern summer. So the counter current is stronger during northern summer. Whereas during southern summer, northeast trades are stronger, but since the extent of Atlantic Ocean is less, despite northeast trades being stronger during southern summer, since the extent of ocean is less, so the piling up of water is less. So the counter current is weaker during southern summer, or you can say northern winter, and it is stronger during northern summer. Now, what we see on reaching the western boundary, this north equatorial current gets deflected along the coast of South America. North equatorial current gets deflected along the coast of South America. Here, if you open up your atlas, you will see as it moves along the coast of South America, it is moving away from equator. It is moving away from, as it moves away from equator, the magnitude of Coriolis force increases. This Coriolis force in northern hemisphere acts towards right hand side. So by the time this current reaches lesser Antilles, here these are islands, open your atlas, lesser Antilles, small islands, These islands act as obstacle as this north equatorial current moves along the coast of South America. It moves northwestward away from the coast. As a result, the Coriolis force increases, which deflects this current towards right hand side. As moreover, the obstruction caused by these lesser Antilles islands, Santigua, St. Kitts, Nevis, lesser Antilles islands. This north equatorial current gets bifurcated into two branches. One branch moves to the east of Lesser Antilles, and the another branch enters into Caribbean Sea. The branch which moves to the east of Lesser Antilles Island is known as Antilles Current, and the branch that enters into Caribbean Sea is named as Caribbean Current. Now, if you see in your atlas, Caribbean Sea, this Caribbean Sea, you can see there's Florida, Yucatan Peninsula, and there's Cuba. You can see this is Cuba, this is Caribbean Sea, and this is Gulf of Mexico. This is Gulf of Mexico. You can see here. This is Gulf. This Caribbean Sea is connected to Gulf of Mexico by way of Yucatan Channel. This is Yucatan Peninsula. This is Caribbean Island, Cuba. This is Florida. Florida. This is Cuba. This is Yucatan Peninsula. Here in Caribbean Sea, the velocity of Caribbean current is very fast. Velocity of Caribbean current is very fast, and it approaches this Yucatan Channel. This is Yucatan Channel lies between Cuba and Yucatan Peninsula. There's huge piling up of water near the Yucatan Channel because this channel is narrow. Yucatan Channel is narrow, and the velocity of this branch of north equatorial current, that is Caribbean current, is very strong in Caribbean Sea. So water starts piling up near Yucatan Channel. As a result, bulk of the water takes U-turn and moves out of Straits of Florida. This narrow water body separating Florida and Cuba is known as Straits of Florida. Bulk of the water moves out without gaining any name. It retains the name Caribbean current. Rest of the water of Caribbean currents make a clockwise arc in Gulf of Mexico, then moves out of Straits of Florida. Because of huge piling up of water, the velocity of current when it moves out of Straits of Florida, it is high. As it retains the name Caribbean current in Gulf of Mexico, but as it moves out of Straits of Florida, now it is known as Florida current. Now it is known as Florida current. Florida current. Florida current continues to move along the southeastern seaboard of USA. If you open your atlas, you will see here there is a Chesapeake Bay. This moves into this, take a semicircular arc in Gulf of Mexico. Bulk of it moves out of Straits of Florida up to Cape Hatteras. There is a Cape Hatteras. This current which moves out of Gulf of Mexico from Straits of Florida to Cape Hatteras, it is known as Florida current. Cape Hatteras is just south of Chesapeake Bay. Chesapeake Bay वही bay है जिसमें Potomac River falls. This is the same river on which Washington DC, the capital of USA, is located. This current from Straits of Florida to Cape Hatteras, it is known as Florida current. Up to Cape Hatteras, it is known as Florida current. Here what happens at Cape Hatteras, this northward branch of north equatorial current, that is known as Antilles current, This Antilles current also merges with Florida current at Cape Hatteras. At Cape Hatteras, this Antilles current merges with Florida current. As a result, the resultant current becomes warmer and broader. The resultant current becomes warmer and broader. And beyond this, it comes under the impact of westerlies. Westerlies. As a result, this warm and broad current from Cape Hatteras to Grand Bank, which is known as Gulf Stream, it moves very fast. Gulf Stream is the result of culmination of water of Florida current and Antilles current. It is warmer and broader, and since under the impact of westerlies, it moves very fast and starts leaving the coast. It starts leaving the coast. The velocity of Gulf Stream is so strong that it appears like river in ocean. If you happen to go to ocean, तुम्हें लगेगा नदी बह रही है ocean में. You can see the water moving. You, these these marine ships, these people align their ship along Gulf Stream to save on fuel. It is just like नदी. तुमने देखा है कई बार पानी water flows so fast in ocean. You can see it like a river moving in ocean. It is so fast, broad and warm, saline, and under the impact of westerlies, it starts moving away from the coast. It starts moving away from the coast at a very high rate of velocity. Because of this, cold water upwells along the northeastern seaboard of USA and southern part of Canada. Huge upwelling of cold water takes place over here. And this is known as cold wall or Cabot current. On the left of Gulf Stream lies the cold wall or Cabot current, which is caused by westerlies, which drags away this warm surface water, which leads to, because the warm surface water is being dragged away from the coast, so cold water starts upwelling along the coast. On one side, upwelling cold water. On the other side, I'll discuss Sargasso Sea, warm saline Sargasso Sea. This Gulf Stream is among the strongest current in the world. It is having huge velocity, and it extends between Cape Hatteras to Grand Bank. Warm, saline, broad, high velocity current. At Grand Bank, it meets Labrador current. Labrador current that has its origin in Arctic Ocean. It is the result of melting of Arctic ice. This moves between Ellesmere Island and Greenland Island. There is a strait, water body, that is Nares Strait. Nares Strait. This is Nares Strait. Labrador current passing through Nares Strait, Baffin Bay, Davis Strait, Labrador Sea. It reaches this Grand Bank and meets with Gulf Stream. Labrador current is extremely cold current and it is very dangerous. Labrador current, under the impact of melting of ice and polar easterlies, it passes through Nares Strait, then basically Baffin Bay, then basically Davis Strait, then Labrador Sea. It meets Gulf Stream at Grand Bank. Its motion of the Labrador current movement is tracked by floating icebergs. बड़े बड़े icebergs लेके आता है अपने साथ. That hamper navigation. That hamper, it is the floating icebergs that determine the direction of Labrador current. And once this Gulf Stream Labrador current mixes with Gulf Stream loses its original characteristics. It no more remains so warm and saline current, neither it retains that strength. It demonstrates itself as a very weak current once it merges with Labrador current. It is said after mixing with Labrador current, Gulf Stream loses its original characteristics and gets divided into various branches. These are known as delta of Gulf Stream. Now, here onwards, this delta of Gulf Stream, it demonstrates itself as a weak, feeble current dividing into various branches. It loses its original salinity and temperature. it becomes a weak current, loses its strength. Now this delta of from here onwards, it is known as North Atlantic drift, because it is now it is a slow moving current. It has lost its original characteristic of high velocity, being very warm and very saline, but still, but now it is very weak, but still it is warm and saline compared to the water body into which it is entering. But it is not so warm and saline as it was previously before encountering Labrador current. One branch of Gulf Stream moves north and takes U-turn and mixes with East Greenland current. East Greenland current and merges with Greenland current. One branch of North Atlantic drift moves southwest of Iceland and impacts the climate of Iceland drastically. This is a warm current known as Irminger current. Irminger current, it imparts warmness to Iceland. Winters may, this Irminger current is a welcome current. It's a warm current. It moves southwest of Iceland. Yet another branch moves further northward, crosses over Waverly Thompson Ridge, and enters into Norwegian Sea. And this is known as Norwegian current. Norwegian current, it is a warm current. Like Irminger current, Norwegian current is warm current. It is this current which is responsible for fishing along the Norwegian coast. It keeps the Norwegian coast open throughout the year. From Stavanger to Hammerfest, cod fishing continues throughout the year. It is attributed to this current. This current keeps the coast open. And not only this coast open, this entire coast of Lapland and this White Sea remains open because of this Norwegian current. Therefore, a large shipbuilding port of Russia is located in White Sea. It is not mere the temperature of this current which keeps the coast open. Rather, this Norwegian current has derived its water from Gulf Stream. So this water has high salinity. Because of high salinity, the freezing point goes below 0 degree. So water does not even freeze at 0 degree. This Norwegian current, not only because of its temperature, but because of its high salinity compared to this ocean, this lowers the freezing point, so the Norwegian coast remains open throughout the year. Yet another branch moves eastward and enters into Bay of Biscay. This is known as Reynolds current. Reynolds current. Still southerly branch moves eastward and southward. South of Canary Island to the west of Africa. This is known as Canary current. Canary current. Canary current is cold current because in the trade wind belt, it comes under the impact of trade wind, and trade wind drags away the warm surface water from the western coast of Africa, and cold water upwells along the western coast of Africa. From Canary onwards, this branch is named, where it is named as Canary current. It is a cold current, and this cold nature is attributed to the upwelling caused by the trade wind. And this gyre of current in Atlantic Ocean is very strong. Nowhere else in the world such strong gyre of current is found. Such strong circulatory motion is found nowhere else. So strong that virtually water at the center of Atlantic Ocean is practically motionless. The gyre of current in Atlantic Ocean is so strong that water at the middle part of Atlantic Ocean is practically motionless. Here we find, because of unique shape of Atlantic Ocean and practically motionless water, here in middle, what we find, floating seaweeds of sargassum. Floating seaweeds of sargassum seaweeds. This extent of sargassum seaweeds define the extent of Sargasso Sea. The sea has acquired its name Sargasso Sea from these seaweeds. This region is practically motionless because of strong gyre of current in Atlantic Ocean. No fresh water by way of river can ever reach here. Why? because strong gyre of current does not allow the fresh water to reach here. There is no chance of ice over here. This is the region of subtropical high pressure belt. This is Tropic of Cancer, subtropical high pressure belt. Here in Sargasso Sea, what we see, it lies in subtropical high pressure region. This sea lies in subtropical high pressure region. So air is sinking. Air is sinking for most part of the year. This sinking air keeps sky clear. So abundant sunshine. Because of abundant sunshine, this Sargasso Sea is characterized by high sea surface temperature. Temperature is high. Here, because of high temperature, lower layers are always full of moisture. High temperature, lower layers are full of moisture. And this sinking air, which gets adiabatically heated, it continuously keeps on absorbing this moisture. So evaporation is very high. High sea surface temperature. Second, high evaporation. Evaporation is very high because here the air is sinking and clouds are absent, abundant heat, high sea surface temperature, lower layers are full of vapor, and as sinking air is dry, it absorbs the moisture. So there is continuous evaporation, continuous evaporation. Because of continuous evaporation, the salinity of Sargasso Sea is very high. So these are the salinity is high. Now here what we see, highly saline water, warm saline water of Sargasso Sea on one side of Gulf Stream, on the other side cold upwelling water. This Sargasso Sea has such certain unique characteristics that here in Sargasso Sea you don't find a single bird, because here in the Sargassum seaweeds their prey can hide in the seaweeds, but Sargasso Sea happens to be the breeding ground of European eels. European eels always breed here because they are safe from their predator and birds cannot find their prey. Here the weather is characterized by extremely humid, warm and humid weather. So this was all about North Atlantic Ocean. Now South Atlantic Ocean. Now what we see, South equatorial current, which was stronger than North equatorial current, when it moves westward, it encounters a sharp edge of South America, Cape Sao Roque, a sharp edge known as Cape Sao Roque. As a result, a part of South equatorial current gets bifurcated towards north and merges with North equatorial current. Only remaining part of South equatorial current turns southward. As a result, the South equatorial current, which was stronger than North equatorial current, because of its bifurcation into two parts, the subsequent current of South equatorial current, that is Brazil current, is a weak current, because a part of it gets bifurcated because of Cape Sao Roque and that merges with North equatorial current. The remaining part of South equatorial current that moves south is known as Brazil current, which is a weak current. Brazil current continues to move up to Plate Estuary, Rio de la Plata, Plate Estuary. Here it is not a strong current. Brazil current is a weak current. It continues to extend up to Plate Estuary. Plate Estuary. Here it encounters Falkland current coming from southern seas. Falkland current passes from Drake's Passage. Under the impact of polar easterlies, it moves along the coast of South America and meets Brazil current at Plate Estuary. Here the Brazil current comes under the influence of westerlies and it starts moving away from the coast. So huge upwelling takes place along Plate Estuary. Therefore, it is very famous for fishing. and Brazil current turns eastward. And here, while moving eastward, it is known as South Atlantic Drift. South Atlantic Drift. From the southern edge of South America, a part of it gets deflected northward. This northward deflected branch is known as Benguela current. It is a cold current primarily because upwelling caused by the trade winds. Upwelling caused by the trade winds. Now, what we see in tropical regions, you will always find cold current on the eastern side of the ocean and warm current on the western side of the ocean. In trade wind belt, you will always find deserts along the eastern margins of the oceans or the western part of the continents because of upwelling caused by the trade winds. See this desert, this is Benguela current, this is the Namib desert, whereas on the western side of tropical lands, you will find lush green vegetation, sugarcane cultivation everywhere, in northern hemisphere also, in southern hemisphere also. In tropics, cold currents are always found on the eastern side of the ocean because of upwelling caused by the trade winds, and warm currents are found on the western side of the ocean because of warm water dragged by the planetary winds. So this was the current of Atlantic Ocean. Now here we move on to Pacific Ocean. Discuss the impact of ocean current on the weather and vegetation. We'll have to write the how do they impact on the weather and vegetation. That is the most important part. Trade winds basically impact on the nature of weather and vegetation by way of ocean currents. It's not merely fishing, rather it is the nature of ocean current that determines the nature of climate not only on the coast but also in the interior. So discuss karenge, we'll discuss it. First you see the currents. This is Pacific Ocean. This is Pacific Ocean. You see in the western side of Pacific Ocean, the bottom topography is very uneven. There are numerous submarine plateaus, fjords, seamounts, islands because of subduction of Pacific plate below Eurasian plate and Indo-Australian plate. Numerous ocean bottom, therefore coral reefs are found in abundance in this part of the ocean. When you see Pacific Ocean, you will be surprised to know that 3/5 of the Pacific Ocean lies in tropics. In Pacific Ocean, the extent of ocean is huge in tropical region. Vis-a-vis Atlantic Ocean, the extent of Atlantic Ocean is very less in tropical region. But in case of Pacific Ocean, its extent is huge in tropics. So these planetary winds blow over considerable distance in tropical region. Therefore, the north and south equatorial current of Pacific Ocean are far more stronger than north and south equatorial current of Atlantic Ocean. Under the impact of trade winds, the north equatorial current starts moving from east to west, and south equatorial current also moves from east to west. North equatorial current, south equatorial current of Pacific Ocean is stronger than north equatorial current of Pacific Ocean because of larger oceanic expanse. Now what we see, these north and south equatorial current are very strong because of huge expanse of the ocean. But what we see, even before reaching the western boundary of the Pacific Ocean, the uneven surface topography, that is because of submarine plateaus, fjords, seamounts, these ocean currents start getting deflected. What we see, a branch of north equatorial current, even before reaching its western terminal in Philippines, it gets diverted, it takes U-turn and contributes to counter current. a part of north equal current gets diverted because of uneven surface topography. Huge piling up of water is taking place. Already the slope on the the sea level on western side is high and it is very warm. So an uneven surface topography causes a part of north equal current to get deflected to take U-turn. It is deflected, it takes U-turn because and contributes to counter current. Remaining north equal current moves up to Philippines, that is uh, southern island of Philippines, and moves parallel to Philippines island. Here you can see Taiwan is there. This is China, coast of China. This is Taiwan. This is northern island of Philippines known as Luzon Island. These are other small islands of Philippines: Sulu, Palawan, Mindanao. This is Mindanao Island of Philippines. This current, north equal current, a branch which reaches to the eastern coast of Philippines, continues to move northward. This is Taiwan or Formosa. Luzon, this Luzon is the name of this island. In between, there's a strait known as Luzon Strait, or you can call it Balintang Channel, or you call it Bashi Channel. इसके तीन नाम, because here islands are there. Babuyan and Batan islands are located. So this channel is divided into various channels. So this north equal current which reaches western boundary moves along the eastern coast of Philippines. A part of it enters into South China Sea by way of this channel, popularly known as Balintang Channel, between Taiwan and Luzon. It enters into South China Sea. This Balintang Channel can also be known as Luzon Strait or Bashi Channel. Remaining north equal current moves along the eastern coast of Taiwan. Now onwards from Taiwan to Japan, it is known as Kuroshio current. This Kuroshio current moves along the eastern coast of Taiwan, and small islands you can see Ryukyu Islands, है ना? Shikoku, Kyushu, and then Honshu. Kuroshio current extends from Formosa, moves along eastern shores of Ryukyu Islands. These are Ryukyu Islands up to Honshu. This is known as Kuroshio current. A branch of Kuroshio current enters through Ryukyu from passage from Ryukyu Islands. It enters into Sea of Japan by Tsushima Strait. Tsushima Strait is between South Korea and Japan. There is a narrow strait which connects Sea of Japan to this East China Sea. East China Sea is connected to Sea of Japan by way of Tsushima Strait. And this current flowing along the western coast of Japan is known as Tsushima current. It is a branch of Kuroshio current that enters through Ryukyu Island, passes through Tsushima Strait located between South Korea and Japan. It moves along the western coast of Japan and known as Tsushima current. This Kuroshio current is just like Florida current of Atlantic Ocean. It reaches up to Honshu coast of Japan. Here it encounters cold Oyashio current coming from Arctic Ocean. Oyashio current is the result of melting of ice and polar easterlies, passes through Bering Strait, Bering Sea, along Kamchatka Peninsula, Kuril Island. Then it meets this Oyashio current, meets Kuroshio current at Honshu coast. And this moderates the nature of Kuroshio current to a large extent. From Honshu coast up to 160 east, this is known as Kuroshio extension. Kuroshio extension up to 160 east longitude. It is a weak current. It is by means no comparison to Gulf Stream. Kuroshio extension is weak current from Honshu coast to 160 east longitude. After 160 east longitude, this gets the name North Pacific current. Now, after 160 east, when it is known as North Pacific current, it is in the form of two branches. North Pacific current is in the form of two branches. One Aleutian current moving north and second moving southeastward, which will later transform into California current. Beyond 160 east, it is known as North Pacific current. North Pacific current is in the form of two branches. One branch which moves northward is known as Aleutian current. This Aleutian current, when it reaches these Aleutian islands, the Aleutian islands hai na? When it reaches these Aleutian islands, this Aleutian current again bifurcates into two branches. One branch that enters into Bering Sea and moves north of Aleutian Island retains the name Aleutian current. It moves in counterclockwise direction. Aleutian current, on encountering Aleutian Island, it again gets bifurcated into two branches. One branch enters into Bering Sea and moves along the northern shores of Aleutian Island. It retains the name Aleutian current. It actually merges with Oyashi current. It merges with Oyashi current and it becomes cold current. The second branch of Aleutian current moves south of Aleutian Islands, and this also moves in counterclockwise direction in Gulf of Alaska. This is known as Alaskan current and it is warm current. Why? Why the same? This Aleutian current got bifurcated into two branches. One retained the name Aleutian current, another branch gained the name Alaskan current. Aleutian current is cold current, Alaskan current is warm current. Why? Because it depends upon the temperature of the water body into which it is entering. Here in Gulf of Alaska, it is surrounded by land on three sides. As this cold static water is very cold. As a result, the branch of Aleutian current which enters into Gulf of Alaska make counterclockwise arc, that is Alaskan current, is warm current because it is warmer than the cold static water of Gulf of Alaska. And the second branch of Pacific current which moves southeastward continues its sojourn and along the western coast of Mexico, it comes under the influence of trade winds. As a result of trade winds, huge upwelling takes place along the western coast of Mexico. As a result, this current becomes cold current. California current is cold current. Now, most important current of Pacific Ocean, if you see, that is counter current. Pacific Ocean is having huge expense. There is huge piling up of water on the western side, huge piling up, and the surface water is very warm. Counter current is always warmer than north and south equal current, whether it is Atlantic Ocean or Pacific Ocean. But in Pacific Ocean, because of huge extent of ocean, huge piling up of water takes place. You will be surprised to know that the temperature of western part of Pacific Ocean is 10 to 12 degree more than the eastern part of Pacific Ocean. 10 से 12 degree because of piling up of warm surface water. As a result of piling up of warm surface water, the strong compensation current is generated in Pacific Ocean. This counter current of Pacific Ocean is very warm and very strong as compared to counter current of Atlantic Ocean. It is very warm and very strong. This is warmer than either north and south equal current. During northern summer, when all the pressure belt, wind belt, ocean current shift northward, Counter current also gets deflected towards north and brings warm waters in the eastern side of Pacific Ocean. California current diminishes, disappears. Northern summers, it weakens California current and warms up the water of eastern Pacific Ocean. This is the only part in the world where tropical cyclones get formed in the eastern part of tropical sea. Always tropical cyclone gets formed on the western side of tropical seas, western side of tropical sea, western side of tropical sea, western side of tropical sea. This is the only part. Why? Because during northern summer, warm water of counter current warms this water body, and often California current diminishes in strength. Just I have to explain southern part also. Let me explain this southern Pacific Ocean, then we will come on to counter current. अभी नॉर्थ ही समझा है ना. साउथ काउंटर करंट को भी यहीं रोक दो, साउथ वाला पार्ट कर लेते हैं. जस्ट कंप्लीट द सदर्न पार्ट. तो नॉर्थ इक्वल करंट था, वैसे ही साउथ इक्वल करंट इज देयर. South equatorial current is stronger than north equatorial current, but because of uneven surface topography, it gets diverted on even before reaching the western boundary. The south equatorial current also gets bifurcated. One branch moves to the north of New Guinea, takes U-turn, contributing to counter current. One branch moves north of Australia through Torres Strait. One branch moves to the east of Australia. This is the branch that brings about heavy rainfall. One branch that moves to the east of Australia, known as East Australian Current. It encounters Great Dividing Range and causes very heavy rainfall along the eastern coast of Australia. Reaching south, it comes under the impact of westerlies and it moves away from the coast. When it moves away from the coast, upwelling of cold water takes place. Therefore, the southeastern coast of Australia is very much known for fishing. And then continues journey through New Zealand, causing heavy rainfall along the western part of New Zealand. Western part of New Zealand is very wet. Eastern part of New Zealand is very dry. Because in the mid of New Zealand, in Southern Island, Southern Alps is there. In Northern Island, volcanic cones are there. Well, volcanic islands are there. So these rain-bearing winds causes heavy rainfall on the western side, while the eastern side of New Zealand remains dry. This current continues to move east. It is wrong to say South Atlantic west. It is known as west wind drift. Drift should not be used because this current is very strong. This current is very strong. South Pacific current is very strong. Huge expanse of the ocean. Encountering this is known as west wind drift. Ideally, it should not be called drift because it is a very strong current. A branch of it gets deflected by the southern tip of South America and starts moving northward. This is known as Peru current. This is the most widely studied current of the world, studied by Humboldt extensively. So it is also known as Humboldt current. It is this Peru current and counter current that plays the dominant role in influencing the climate over half of the globe, especially in tropical regions. This Peru current is basically because of upwelling caused by the trade winds. Upwelling caused by the trade winds. And it again joins south equatorial current. So this was remaining. Now what I was discussing is counter current. I was discussing counter current is basically the result of piling up of water and it moves as a compensation current. It is warmer than north and south equatorial current. During northern summer, all pressure belt, wind belt move northward. So this current also get deflected northward. And Peru current extends beyond equator and meets this counter current north of equator. It meets this counter current north of equator every northern summer. Every southern summer, when the pressure belt and wind belt shift southward, this warm counter current southern summer will shift southward. It shift, it turns southward. All the currents will turn southward. During southern summer, northeast trade will cross equator and turn leftward, southward. This counter current turns southward, encountering the coast of South America. It moves south. It moves south. What we see during southern summer, we encounter two different types of surface water. Two different types of surface water in eastern Pacific Ocean. Warm water of counter current moving from north to south, lying on the right hand side of cold Peru current moving from south to north. This happens every year. Two different types of water, surface water is found in the eastern part of Pacific Ocean. Warm water moving from north to south along the coast, and cold Peru current lying, this warm current lying on the right hand side of Peru current. Cold Peru current moving from south to north. This phenomena occurs every year. Two different types of water masses are found. Water uh, types are found every year. In certain years, this counter current is so strong that it ends up warming up of entire East Pacific Ocean. Certain years, this counter current is so strong that it warms up the water of East Pacific Ocean, also known as sea fever, so much so that Peru current disappear. During those years, this counter current is known as El Nino current. ये केवल इंडिया में ही है, वरना एलिनो को कभी करंट नहीं कहते हैं. एलिनो इज अ मेट्रोलॉजिकल फिनोमिना. इंडिया में ही कहते हो, यूपीएससी में एक्सेप्टेड है. During those years when counter current is exceptionally strong and it ends up warming up eastern surface water of Pacific Ocean, those years this counter current is known as El Nino current. El Nino is defined otherwise globally. कहीं तो मैं El Nino current इंटरनेट पे लिखा नहीं दिखेगा, केवल इंडियन बुक्स में इंडियन स्कॉलर मानते हैं, यूपीएससी मानता है इसको, क्योंकि तुम यूपीएससी एग्जाम दे रहे हो तो लिख के आओ. El Nino is a meteorological phenomena associated with the warming of East Pacific Ocean. Bas. This El Nino current, counter current is known as El Nino current, and it's so strong that it warms up the water of entire East Pacific Ocean and even crosses the southern tip of South America and joins the South Atlantic drift and reaches up to Indian Ocean in the month of June. This phenomenon takes place in December, southern summers, and this counter current becomes so strong, so warm, that is warm water travels from December, and by the month of June it reaches South Indian Ocean. June is the month of monsoon, where surface is hot and Indian Ocean is cold. So high pressure prevails over here. Whenever this warm water reaches the southern Indian Ocean, it warms up the cold water. As it warms up the water, this high pressure of southern Indian Ocean is weakened. As a result, monsoon becomes weak. ये इंडिया में एक्सेप्टेड कंसेप्ट है, यूपीएससी में एक्सेप्टेड कंसेप्ट है, वाहियात कंसेप्ट है, लेकिन यूपीएससी में एग्जाम में यही लिख के आना है. What is the actual reason I will discuss, which is accepted both by India and world. But this is what Savinder Singh, who has been the member of UPSC, evaluator of UPSC, writes. Counter current is known as El Nino current, and this is how El Nino, warm water of El Nino influence warms up the water of South Indian Ocean and weakens Indian monsoon. This is what you have to write in exam, but it is totally absurd. मतलब सभी कहते हैं meteorological teleconnection. This monsoon takes place in June, El Nino takes place in December. When two phenomena are separated by a long distance and long span of time, but still they impact each other, are known as meteorological teleconnection. So now I will explain you how actually what happens, how El Nino that is warming up of eastern part of Pacific Ocean, how actually it influences the Indian monsoon. We will continue it tomorrow, and tomorrow I will discuss the impact of El Nino on monsoon and how it actually influences Indian